one is about which parametric equation gives you the ellipse in the question. So easiest way to start is by looking at those parts of the ellipse equation. So you know that whatever equation's here has to give you something similar to this, like this and this. But again, you have to keep in mind that's only if you're using a rule like cos squared t plus sine squared t equals 1. Because if the parametric equations use a different rule, then it might not always be in this form, but generally this is the form you look at first. So if you look at some of the options, like C, for example, you know it can't be C because if you rewrite it, then you get x minus 2 on 9, but if you square it, you get 81 as the denominator, but it should be 9, so it's not C. Same thing with D, except you have a 2 here and a 3, but you would want to swap them around. And basically just test all of them like that. But if you just do a quick scan of them, you'll see that E is right because they has a cosine sign, which is the easiest one to like check in your head. And if you rearrange that, you just get this. So the range of the function for this one, you just graph it on your CAS. It looks like this. So you kind of know all of them are wrong except A, because you can clearly see when you graph it that the maximum is at 0. So question C. So both A and C are non-zero real numbers, so this cannot represent. So it kind of, with trial and error questions, you should probably start from the bottom, because they're more likely to put the answer at the bottom, because like if they put it at the top, then everyone would get it really quickly. So like start at the bottom, and if you start at the bottom, you can kind of see these two, and that's like the hint. So so if we want to rearrange the relation, we can write this as y equals something or x equals something. But if we're checking the bottom two, you have to write it as y equals something. So you could write it as y equals c minus a squared x squared divided by 1 minus x a squared. So if we're looking for lines, then we can get 2 lines, because when we square root this, we'll get plus or minus square root of that. So like by checking this answer, we know that D is wrong because you can get 2 lines. So it can't only represent a single line, especially because they don't give us any restrictions on A and C that would suggest that there's only 1 line. So question 4, asymptotes are given like this, and it's asking you what's the hyperbola. So first thing to look at is the gradients. So the gradients have to be made by the number under the y over the number over the x. So for this, if we test from the bottom, I guess that's what I said to do, it works out because we have 4 and 9, so square root 4 on square root 9 is 2 on 3. So that matches. For this one, it also matches. This one, it doesn't, because you get 3 on 2. This one also, and same with this one. So now you only have these 2 options. And then after that, you could just test in the points that they give you, and you'll get the answer as D. So this one given C is this, the modulus and the complex. So to do this, you could just simplify this by like times it, or multiplying both the denominator and the numerator by the conjugate, and you end up with 1 plus root 3 plus root 3 minus 1i. Looks complicated, but if you put it into your CAS using, I think it's, let me see what the setting is. It's comp to trig. If you chuck that in there, you get, it kind of gives you cis form, but it will say like root 2 cos pi on 12 plus sine pi on 12i, which is basically cis form expanded. So that function is really helpful if you can find it on your respective CAS. But yeah, now you know that z is root 2 cis pi on 12. And if you do z to the power 5, you just multiply this one to the power 5 and you multiply the argument by 5. So you can easily see that the answer is B. Question 6. So there's a complex plane. So if it's one of these questions, it always helps to draw what's happening. So we have 1 plus 2i here. So this is 1. This is 2. And it's asking for which one passes through the point. So again, with trial and error, because this is trial and error, you have to start. Oh, sorry. My scale is way off. It's 1, 2. So trial and error always start from the bottom. So x plus iy plus x minus iy equals 2. These will cancel. 2x equals 2, x equals 1. And you can clearly see that's the answer because it goes through the point. So that's why you always start from the bottom. But if you test the other ones, like this one, x plus iy, x minus iy equals root 5. Square y squared equals root 5. And you might think that's this equation because this is root 5. So like circle goes like this, everything makes sense, A is the answer, but it's not because the circle equation, this is actually r squared. So if this were to be true, then this would have to be the square root of the square root of 5. So that's why it's not A. And yeah. So question 7. For this one, you can just easily you don't have to do anything. You can just put this into your CAS and make it to the power of 63, and it'll quickly give you an answer. I got like -5. There was a lot of numbers, but it's negative and it's a real number. If you look at the end, there's no I. So that's pretty much it. You can just see that it's real and negative. So which one does not represent a circle? Well, we already know this one does. Like you just know because you know if you expand it, you'll get that form. I'll just write it because so equals 4, so x squared plus y squared equals 4. We know that's gonna definitely give you a circle. So then trial and error will start from the bottom. So this one would be square root x plus I'll just write plus 2 plus 4. That's kind of complicated. We don't know if it's a circle or not, so I'll probably skip it and come back to it if the other 3 don't work, or they do work because it's asking for the one that doesn't work. So for D, we do x minus 1 squared plus y plus 1 squared equals 4 squared, so x squared minus 2x plus 1. Oh, we don't even have to do that. We can just see it's a circle, so it's not D. C, x squared plus y minus 1 squared equals x plus 2 squared plus y squared. So this one we know is not going to be a circle because if you expand all the terms like this, you can see that the squared terms on both sides cancel, so you're left with a linear equation. So C is your answer, and that helps because you don't have to figure out what this is. So question 9, statement that is necessarily true. So if this is Z1, then that's theta, and this is, I'll say, I don't know, alpha. And since it's been multiplied, that means alpha is equal to theta 1 plus theta 2, because you can see the angles here. So it's asking for the statement that has to be true. So it's not something that might be true, it has to be true. So R2 is greater than 1. That's not true because if R2 was greater than 1, since when we multiply in complex numbers, if R2 was greater than 1, then the mod of this, so the length from the origin, would be greater than where Z1 was originally. So if we draw like a radius circle, if A was true, this dot would be like somewhere further away from this circle, but it's less than, so we know that R2 is in fact less than 1. theta 1 is less than theta 2, so theta 1 is this one, and it's saying that theta 2 is less than theta 1. We don't really know that, like, there's nothing, it could be true, but we don't know. C actually simplifies to, because the mod of Z1 is R1, R2 is greater than R1, so it's just saying, I'll just, if you cancel both sides, it's just saying R2 is less than 1, which is true, but if you look at this, like, it kind of looks complicated, so you can skip it and go to D. And you know D is also not correct because we don't know anything about alpha. We don't know how much this is. So we don't know if alpha is 2, theta 1. So we don't know D. And E, R1 is greater than 1. We don't know that because we don't know like what this length is. It could be 0.7. We don't know what the R is. It's not E. So by elimination, you get C. But also, if you simplify it, you also know that it's C. Yep, so that's question 9. Question 10. So suitable substitution. With this question, like you kind of need, I guess, experience or just like having done other questions to know which part to substitute, but you can easily see that the 3x plus 1 is going to be the problem. So you get rid of the problem by substituting something else. So let u equals 3x minus 1. So dx is 3, dx is 1 on 3 du. Okay, so for this question, all of the middle parts or like the substituted expanding stuff is the same. So there's no point in us doing that as well. So we have to eliminate answers by looking at the other things. So the first thing to look at is the terminals. So the true terminals, if u is 3x plus 1, when x equals 1, u equals 4, and when x equals 0, u equals 1. So the terminals have to go from 4 to 1. So it's not A, it's not D. And then the last thing we can look at is the coefficient in front of the integral. So for this, we kind of do have to like expand this a bit, but not really, because you can see the only thing that would affect it would be when you square it and this part. So if we rearrange this to find x, u minus 1 on 3. So this would be 4 to 0, 4 to 1. And then x squared is this squared, so u minus 1 on 3 squared. And square root u du times 1/3 du. So you can see that this factor and this factor will give you the coefficient. So it's 9 times a third, so it's 1 on 27, and that's D. So velocity time graph, and it's asking for when it goes to the initial position. So if it's going to the initial position, then displacement is 0, and displacement in a velocity time graph is the signed area under the curve. So at one point, the area on top has to equal the area on the bottom. And like, you kind of have to guesstimate with this question. You can see that it's definitely going to be past 2, but it's probably going to be less than 4 because this area looks like bigger than this area since this point is lower than this point. So the answer should be somewhere within this range. So 0 to 0.5 is not it. 0.5 to 1.5 is not it. 1.5 to 2.5, so that's saying it's somewhere here. So the only really valid region from that answer is here, but that's a bit small because you can see this area right here is probably not going to match this area. 2.5 to 3.5, so that's saying here somewhere, and that's correct. That makes a lot of sense. But once you go to 3.5 to 5, like here, the area on top, we might be bigger than the area on bottom, so we don't really know. But so the safest answer to go with would be D. Sorry. So this is just differential equations. So if you have dy dx, 1 minus y on 3, you can swap or flip it. So dx dy equals, sorry, I'll just write this as a fraction. So y on 3 minus y equals 3 minus y dy, and that's oh, sorry, this is 3. So yeah, so you can see this is easily your log integral. So plus c, never forget the constant. And since they give you the boundary conditions, so you can sub them in to find c. So 3 minus 4 plus c. Oh. So 2 equals negative 3 ln minus 1 plus c. Since this is a mod, you can equate this whole thing to 0. But if it were a bracket, then you'd have to leave it in, because technically it's undefined, but that might be because it becomes defined when you sub c into the whole thing. But since it's a mod in this case, you can just cancel it and make it 0. So then c is 2, and then you put c back in here. Negative 3 ln 3 minus y plus 2. So that simplifies to 2 minus x on 3e 3 minus y equals. So if you look at the answers, the 3 has to be positive, so it's not A. There has to be a 3, so it's not C or D. And this part, if you look at it, the answer is B. So question 13, draw the solution curve for the differential equation at this point. So you find that point that's here-ish, and you just have to be very careful when you continue the graph, because if you muck up a bit, your answer is going to be very wrong. Oops, sorry, my laptop bits. So if you follow it up, like, that's already wrong. So just make sure the gradient's like not harsh. Like you want to follow the gradient. I'm just gonna follow it. Something like this. And you have to go the other way as well. Right, so then it's asking which other point does it pass through. So that's the reason you have to be careful, because if you draw a graph like if you just don't care, it's going to pass through different points. So just be very careful when you draw your graph, and then this is trial and error. So start from the bottom. Sorry, negative 0.5 and 2. So here, that's nowhere near the graph we drew, so it's not E. 3 and negative 0.5, that's here. That's very close, but with these questions, you want to check all the answers in case there's a closer option. So 3 and 1 here, close, but not as close as this one, so not going to consider it. 1 and 2, not close. 0 and 2, not close, so the answer is D. Question 14, so this is also trial and error, just this one you can just easily do on your CAS. Just differentiate it twice, and sub it into each equation, and just you can use the judge function, or you can just use the left-hand side and check if it matches the right-hand side. Doesn't really matter, but trial and error, and the answer is E. So the component of the force F in the direction of W is, so this is basically asking you to find the parallel vector resolute in the direction of W. So the formula for that is A dot B on B dot B times B, but in this case, is A is F and B is W, so F dot W on W dot W times W. F dot W is A plus B, W dot W is 1 plus 1, and I plus J, so you can see this simplifies to A, because I plus J is just W. So question 16, this is a bit like, they kind of trick you if you're not paying attention. So it's held in equilibrium, and it makes an angle of 60 and 30 with the ceiling, and it's given that these are the tension forces. And the correct statement given the forces is, so the trick with this question is the answer is actually A, And all of these angles are just to trick you. And the reason for that is, so like if you use vector, like if you resolve everything into components, so if you do it vertically, so you get W equals T1 cos 30 plus T2 cos 60. So T1 on 2, root 3 T1 on 2 plus root T2 on 2. Or is it the other way? Let me check. Wait. Oh, it doesn't matter. But if you get something that looks like this, and check your answers, you might think one of these is right, but it's not, because each of these has a tilde underneath it, which means you're adding not just the magnitude of the tension force, you're actually adding the direction as well, which is wrong, because when we use vector resolution for components, we only consider the magnitude. So that's why that's wrong. So that means the only ones that could be correct are A and B, because they're the ones, since everything has a tilde underneath it, we're dealing with the actual vectors here, not just the magnitudes. So if something's in equilibrium, then the addition of all the vectors has to be true. So that's why it's A. So yeah, just that's the trick with that question, is because everything has tildes. We have to consider the vectors, not the magnitudes. So question 17, so it's asking for the cosine of the angle. So cosine is, well, in this case, since it's ABC, the angle would be like at B, so you would have to find BA and BC. So I got BA is negative I plus 2j minus k, and mod BA is root 6. BC is negative 3i minus 2j, mod BC is root 13. You have to have BC and not CB or AB, because when you do the cosine of an angle, it has to be from like head to head. So you have to start with B going that way and that way. You can't do it like that, because then the angle that you would calculate would be this one and not this one. Yeah, so and then you just do cos alpha or theta equals BA dot BC on times BC, and if you just sub these values in, you get C. So position vectors given, particles will collide. So the thing with this question is you check if it says the particles will collide or if the parts will collide. If the particles will collide, you can just equate either component. The easiest component to equate would be the J component, because it's like a squared. So 3t plus 2 equals 4 plus t, and then you just get t equals 1. So if you sub t equals 1 back into either equation, either part, so the easiest to sub it into would be 6t, because it would just be 6. And then you look for the answer that has 6i in it, so that would be B. If it had said where the parts collide, you would have to make a Cartesian equation and then for both of them, and then equate those together. Question 19. So this is accelerating upwards at 9 on 2. Sorry, not 9. G on 2, ms minus 2. And it's asking for m. So to do this, we have to use F net equals ma, Newton's second law. So since it's going up, then this is going down. So the net force, like, you consider this is like positive, I guess. So mg minus 1 times g equals m plus 1a. You have to do m plus 1 because we're considering the whole system, and a is g on 2. So you can just cancel g on all sides. So m minus 1 equals m plus 1 on 2. So 2m minus 2 equals m plus 1. M equals 3. So it's C. So an object is moving in a straight line. initially it's 5, and then 16 seconds later it's moving the other way at 11 in the opposite direction, so the acceleration is constant and t is 16. So this is just your constant acceleration formula. So you have u is 5, v is -11, t is 16, and you want to find s. So the equation would be half u plus vt, because you're looking for the one that doesn't have acceleration. And if you just sub everything in there, you get -48, but it's just asking the distance, so it's not signed, so you can take out the negative, so it's b. Question 21, so equation in the horizontal direction, so this way. So there is a friction force, and friction is mu Fn, so Fn is this one. And this would be F cos theta. So if we do F net equals ma, capital M, because the mass is capital M. So F cos theta minus mu Fn equals ma. And I guess the trick with this question is to realize that Fn is not equal to mg like in other cases, and mg, because there's a rope, so there's a vertical component of this as well. So you have to do the same thing, force resolution, I guess, vertically. So Fn plus F sine theta equals mg. So Fn is actually equal to mg minus F sine theta. Sorry, it's capital M. And then you could just sub that in here, or you could just look and you can get rid of A and B because they're wrong. And you can get rid of C because it should be F cos. And then if you sub this into here, you can see it's going to be E because this is the other way around. So D, there's a ball is turned vertically up with initial velocity 7√6. This is the acceleration, and X is displacement, V is velocity, and the time to reach its max height. So this is where you have to choose which acceleration formula you're going to use. So since it's asking for the time with the maximum height, you're going to have to find something with x and t. So if we have a equals -9.8 plus 0.1 v squared. Oh, sorry. It's okay. So for this one, it's actually v, because we don't know what the max height is, but we know at the max height v equals 0. So we have to find something in v and t. So the easiest one would be dv dt equals -9, why there's a negative there, 0.1 v squared. And then you could swap it and integrate it. So 109.8 plus 0.1 v squared. And you could put that into your CAS and then add a c and then sub 0 when t equals 0, v equals 7√6, and then you'll get an equation of t in terms of v. And then you want to rearrange that to find v in terms of t, and then sub, I don't know, sorry, you get, well, it doesn't really matter because you could just sub v equals 0 anyway, and then just solve for t using the equation from here. But you should get t. I think if you put it into your CAS, you actually get 10 pi, oh no, you get 5 pi root 2 121 or something like that. Yeah, I just, do you? Oh, you get something that looks like, yeah, no, you do get this one, but make sure you don't choose B because the root 2 is in the wrong place. And if you simplify this by multiplying both sides by root 2, you actually get D. Yeah, so that's the multiple choice.